Monolithic versus microservice architecture. So let's imagine you're in charge of a medium-sized e-commerce organization. Unfortunately, your software stack was created over 12 years ago and it's architected as a monolithic system, tightly coupled. A simple change requires weeks of testing to redeploy the entire application. Each change then requires to be added to the release backlog of your team, and your application can only be released as a large deployment of monolith. Worse, your entire application is using the same programming language and database. After all, it's a monolith. So you're unable to look into innovative concepts that your competitors have already adopted around machine learning, for example, as you cannot adopt this new exciting data lake capability which does not integrate with your legacy application. You're stuck in time. And let's face it, if you're still here in 2022, you will probably be bankrupt soon. So you better take action now if you haven't already. That's when moving to microservices is critical. But what are microservices? A microservice is a software development technique, a variant of what we used to call service-oriented architecture, SOA. It's an architectural style that structures an application as a collection of loosely coupled services. In a microservice architecture, services are fine-grained and the protocols are lightweight. The benefit of decomposing an application into different smaller services is that it improves modularity and makes the application easier to understand, develop, test, and makes it more resilient to architecture erosion. It parallelizes development by enabling small autonomous teams to develop, deploy, and scale their respective services independently. It also allows the architecture of an individual service to emerge through continuous refactoring. Microservice-based architectures enable continuous delivery and deployment. Effectively, what this means is that you can decouple teams, cut your work into services and Lego blocks that are loosely coupled, and by using the concept of domain-driven design, DDD, you learn how to cut the right buckets so they are not overlapping and not tightly coupled, so that each team can now do their own work without having to coordinate the work across teams. You're accelerating your velocity. Now, let's take a deeper look at your e-commerce system that is comprised of different capabilities which could be cut into domains using DDD. The key is to make sure you're not cutting things that belong together, as this will make the situation worse due to tight coupling. Services must be able to function independently, but may depend on each other from time to time. So let's quickly compare here a monolithic system with a microservice architecture. On the left here, you see your monolithic architecture with your UI, business logic, and data access layer all into one stack. On the right, though, you see your microservice architecture where the UI is separated from each microservice, often talking to each other through APIs, and each microservice is now decoupled, yet can communicate, of course, with each other as needed. So if you think of an e-commerce application, you could have a billing, product, user, search, and payment microservice all having to interact, but being able to be built separately by different teams. So let's take a look now at a deeper example of a microservice architecture. Here, as you can see, you could have different devices, maybe a mobile device and a desktop, and through the API gateway, the device is able to communicate with the microservices. Each microservice is cut into the proper domain to avoid overlap and making sure that they are loosely coupled with each other. You can see here a passenger management, microservice billing, driver management, the trip management and notification service, and payment service. All of these services can interact and may depend on each other to some degree, but they can be built and developed using different technologies, different databases, so you can use the best tool to get the job done. And more importantly, you can staff them by using the concept that came from Amazon called the two-pizza team. The two-pizza team is effectively defines the size of your team per service, effectively a team that's going to be able to be fed with 2 pizzas. Of course, if I'm on the team, then I'm going to eat a lot of pizza, so you're going to have a much smaller team. So here, as you can see also, we could have a notification service, but also you could have a recommendation service that could be using AI/ML to recommend different options to your customers. In this case, of course, they would use a very different kind of technology, which effectively enables the use of modern AI/ML capabilities. And because you're not tightly coupled in a monolithic architecture, now you have options to pick from, and you're not stuck in the same tech stack for your entire application. Everything is Lego blocks. You can swap them. If you have to upgrade the billing service or the payment service, you can do canary releases on each service, and you don't have to coordinate releases between services. You're very nimble because now you can do A/B testing, you can bring new features, you can try things out, and you can swap services without having to replace the entire application. There you have it. By leveraging microservices, you decouple your teams, allow the release of features as separate release cycle, enable teams to use the best tool to get the job done, and more importantly, have the flexibility of swapping Lego blocks as needed and sharing them across the organization. So if you look at learning more about how to properly cut monolithic application into microservices, check out Domain-Driven Design. Also check out our video on the Strangler pattern, which enables you to move from your monolithic application to microservices at the place of relevance while improving your application as well.